doing? I hope you're well. And then on this video, we'll be doing graphs, right? So on this one, we are given a quadratic graph, and the question says, given f of x is equal to negative ax squared plus bx plus 6. Then it says the gradient of the tangent to the graph of f at the point negative 1 and 7 over 2 is 3. Show that a is equal to 1 over 2 and b is equal to 2. So first things first, now it's like, okay, tangent, the gradient of a tangent. Which tangent? Because usually you are used to being given a tangent such as y is equal to mx plus c and all those things, and you're also used to given the function in full without a and b, okay? But now this one is different. They now give you the function, and with the function that you are given, you don't have the variables a, and they just give you variables. You don't have the values of the variables. They're asking you to find that. So now the interesting part is the part where they said the gradient of the tangent to the graph. The gradient of the tangent to the graph is 3, right? So now one thing to remember is that we are given a quadratic function. So the gradient of a quadratic function is the derivative of that quadratic function. Okay, let me just note that. The gradient of a quadratic function is the derivative of the function. I hope that's the correct spelling of the function. Function. Yes. Okay. So what do we mean? No, I think it's a derivative. I don't know. Anyway, after that, that means f of x is equal to f prime x, right? That's what we mean when we say the gradient of a quadratic function is the derivative of that function. So that basically means that for you to find the gradient, which is 3, you first need to find the derivative of the function that you're given. Okay. Let me fix the spelling of derivative. I get happy with it being like this. Okay. Derivative. Okay. Anyway, so let's start. Okay. A, negative b, negative ax squared plus bx plus c. So your function is f of x is equal to negative ax squared plus bx plus c, and the point you are given is negative 1 and 7 over 2. So negative 1 and 7 over 2, and then you're given the gradient, which is m is equal to 3, but m is also f prime of x is equal to 3, and we need to show that a is equal to 1 over 2 and b is equal to 2. Okay, sorry, b is equal to 2. Okay, so now how do we do that? Firstly, find the derivative, which is f prime of x. Okay, so you're going to say f of x, you are given it's negative ax squared plus bx plus c. The derivative f prime of x is going to be, you bring down the 2, negative 2ax plus b. Remember, the derivative of x is just 1, hence why we are left with b over here. But remember, you are told that f prime of x is 3, which means the gradient is 3. So you're going to say 3 is equal to negative 2ax plus b. But then remember, you are given the point. You're given the point, which is negative 1 and 7 over 2, right? It means at x, at this value of x, which is negative 1, the gradient at that point is 3. So which means for x, at the position of x, or for the value of x, the value of x is negative 1. But for that negative 1, you get a gradient of 3. So that's what you should substitute into this equation, not the 7 over 2. Okay, so in this case, 3 is also our y. So 3 is many things here. 3 is y, 3 is f prime of x, 3 is also the gradient, right? So f prime, if you substitute negative 1, it gives you 3. That's what we are saying. Okay, so this means that 3 is equal to negative 2a of negative 1 plus b. Okay, so what does this become? It's 3 is equal to 2a plus b. But now we have two unknowns, so we should turn this into an equation, and we're supposed to have two equations as well. So if you have two unknowns, you should have two equations. So 2 unknowns is equal to 2 equations. 2 equations. Okay. So what are your unknowns? We have unknown A and unknown B. So you're going to have equation 1 and equation 2. So let's turn this into an equation. So it's going to be 3 minus 2a is equal to b. It's already an equation, but let's make one variable subject of the formula. Okay, so this is equation 1. Okay, I hope this makes sense. But now, the second equation is going to come from the original equation where we just substitute the point negative 1 and 7 over 2. Okay, so I'll just rewrite the equation here. So we have f of x is equal to negative ax squared plus bx plus c, and the point is negative 1 and 7 over 2. So the next thing you do, you just substitute these 2 points into this equation over here. So this is your x and then this is your y. Okay, so substituting, it becomes 7 over 2, which is y, is equal to negative a. What is your x? Negative 1 squared, don't forget the squared, plus b of negative 1, c was 6. What am I doing? Sorry, this is 6 over here, 6, and this one is also 6 over here. Okay, so plus 6. Okay, let's just check. Yeah, it's 6. Okay, then you're going to have 7 over 2 is equal to negative a times 1 minus b plus 6. Okay, which becomes 7 over 2 negative a, this is b, minus b plus 6, and then why do I keep writing c? Okay, 6, and then you're going to take one variable to the other side so that you are left with one variable being the subject of the formula. So it's 7 over 2, you can say minus 6, minus b, no, plus b is equal to negative a, and then you can say negative 7 over 2 plus 6 minus b is equal to a. So this is your second equation. Okay, so you now have two equations. First equation being 3 minus 2a is equal to b. Second equation being 7 plus 6 minus b is equal to a. Okay, so continuing, now we can solve simultaneously. Okay, solve simultaneously. Okay, now it means that you substitute equation 1 into equation 2. So substituting 1 into 2. Okay, what is equation 2? Equation 2, it's negative 7 over 2 plus 6 minus b. So we said b is 3 minus 2a. So this will be 3 minus 2a, and then is equal to a. So let's solve for a. Okay, so if we are to remove our denominator of 2 everywhere, it would be negative, let's just say 2 into negative 7 over 2 plus 6 minus 3 minus 2a, okay, square bracket, is equal to 2a, is equal to 2a. Then you are left with negative 7 plus 12 minus, solving this, it would be negative 6, then plus 4a is equal to 2a. Okay, now what are you left with on this side? 6. Okay, 6, 12 minus 6 is 6, and then 6 minus 7. Okay, you're left with negative 1 equal to 4a, no, 2a, 2a minus 4a. Negative 1 is equal to negative 2a. Then dividing the 2, negative 2 divided by negative 2, 1 over 2 is equal to a. So is that what they said a is supposed to be? Okay, so a is 1 over 2. Then we can solve for b. Okay, so b, we said b, let me just say solving for b. So solving for b. Okay, when you start solving for b now, you're going to say So b is equal to 3 minus 2a. So we found what a is. A is 1 over 2. So when you substitute, b is equal to 3 minus 2 of 1 over 2. B is equal to 3 minus 1. B is equal to 2. Okay, is that what our final answer is for B? Yeah, B is equal to 2. So you're able to solve with that. So the key here is understanding that the derivative of a quadratic function is the gradient of a tangent. That's the most important thing to remember. And then after that, they can then say, okay, what is the equation of the tangent? So that's when you're going to say y is equal to mx plus c, but you already have m, which is 3. You already have the point, which is, what's the point? Negative 1 and 7 over 2. The only thing that will be left for you to do is to solve the c. So we'll see, is there any question that asks us to do that? Okay, they don't ask us to do anything like that. We are not asked to find the equation of the tangent. So yeah, I'll just leave it there for now.